Okay, hello all of you Math 8 students. Watch this entire video. I'm going to pause it a few times and give you a chance to ask or answer some questions and make some predictions. But I'm just going to show you examples of some of the questions that you're going to be working on today in your classwork with your groups. And these are also big themes that will come back over and over again throughout the year. So there's two questions here, and I'm doing this on a Jamboard, and just to show you that it's a useful tool also. For example, I was able to put a graph grid background, and graphs paper is always useful. So let's get right into it. This is out of your CPM book. This is question number 9. And for your classwork, you're going to be doing question number 10, which is very similar. So this question is all about starting to understand patterns of how things grow, and we will be looking in much greater depth of this throughout the year. So what you see here are figures 2, 3, and 4. So what's implied is that the first figure will always be figure 1, but figure 1 is missing. So that's going to be right here, and we're going to have a question asked about that. And then figure 5, 6, 7, and so on to infinity. So question A asks you to draw the first, fifth, and sixth figures on your paper. In order to do this, you really have to do question B first. You have to understand how is the pattern changing. So everybody has their own strategy for this. The way that I like to think about it is to kind of look at literally what is changing. So starting with figure 2 and figure 3, I see that there's a rectangle here. And then there are tails coming off this rectangle right here and right here. Okay, everybody breaks these up differently, but if you look at then at figure 3, there's a rectangle, but that rectangle has grown by one column in each direction. So this is all new compared to the figure before. And the tails, this one here is still the same, but this has gotten one bigger along there. Okay, so let's see if that pattern continues. Looking at figure 4, we have still a rectangle, and what you see is it's now, so here's our rectangle. Now compared to the figure before, it's also grown by one row on the top and one row on the bottom, so all of this is new. And again, if you look at the tails, this one is still just 1, but this one has gone from 2 to 3, so that's new. Okay, so there's our growth pattern, and that kind of, we can put that in words in a second, but that at least tells me that I can make an attempt at what figures 1 and 6 will be. So let's work backwards first. So figure 1, if we work backwards, if each time we're adding a row and a column, then I guess that would imply that going backwards we're going to subtract a row and a column. So if we take away a row and a column, we're just left with 2 squares. And our tail shrunk by 1 over here, but so just to put some colors around this to see what happened here, there's our rectangle in the middle, and there is our remaining tail. So we think that there's just going to be 3 there. By the way, we should have probably counted these. So up here we had, on figure 2 we had 8. And here we had 4 by 3, 12, 13, 14, 15. And here we had 1, 2, 3, 4 by 5 is 20. So, all right, so that was figure 1. Now figure 6 is going to be the 1, 2, 3, 4, 5 by 4, but we're going to add a row and a column, so it's going to be 6 by 5 on the rectangle. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So there's our rectangle. Our tail is going to go from 3 to 4. 1, 2, 3, 4. And this stays at 1. So we have 30, 1, and 4. So here we have 35. So the question, how is the pattern changing? So on B, the first thing I always look for, is it changing by the same amount each time? Well, the answer is obviously no, because we can make a table here, and we can say that figure number and tiles, figure 1 we have 3 tiles, figure 2 we have 8 tiles, figure 3 we have 15, figure 4 we have 24. Whoops, over here, that was a mistake, that was figure 5. Figure 5 we have 35, and this one is increasing. If you look at the difference between 8 and 3, that's adding 5. From 2 to 3, you're going from 8 to 15. That looks like it's adding 7. From here to here, that's adding 9. From here to here, you're adding 11. And so the question is, if you can see a pattern there, I'm going to pause the video for a second and let you answer this question. Based on the pattern you see, how many tiles do you think are in figure 6? Okay, so hopefully you saw that each time you're adding 2 more tiles than you added the previous time. So if we added 5, 7, 9, 11, the next gap should be plus 13. And so that would get us up to 48, and you could confirm that by drawing the pattern for figure 6. Now, always the most challenging question is to stretch this out to some number of figure that we don't actually want to draw. So the 100th figure is going to be very large, and we don't want to draw it. I don't have room for it on my graph paper. And so you have to kind of try and think through can you figure out your pattern in some sort of formula? And I will just be completely honest, these are really, really hard for some people. They're hard for me, and I have to kind of just think through it. So you might see me here a little bit struggling to think through it, because I don't have the answers in front of me, because I'm going to work through it just like you would. So, I mean, one way you could do this is continue your figure, or your table, and write 7, 8, 9, 10, 11, all the way up to 100. That would take you a long time, and I'm guessing that nobody's going to go through that. So then the other thing to think about is there some way we can take this pattern of like rectangle size? So just for example, I'm going to go back up to figure 4 here. In figure 4, the rectangle was 4 by 5. So one way to think about it is the figure number is right here. So that's 4. This is the figure number, but one more than the figure number always. This is figure number, but one less. And this is always just a number 1. So knowing that, I could just draw this generic shape. We know there's going to be a rectangle. We know there's going to be a tail. We know there's going to be a square here. We know this is going to be 1, and if it's figure 100, we know this is going to be 100 squares. This is going to be 101 because it's always one more than the figure number. And this is going to be 99 squares because it's always one less. Well, a rectangle here, that's the biggest one, is 100 times 101, so you can't see me, but I'm taking out my calculator. In this class, you can use calculators for things that are just going to be tedious work. So 100 times 101 equals, that's 10,100, plus another 99 plus 1 is another 100, and we should get 10,200. Okay, so as with all videos, I recommend that you pause it, rewind it. As you're working on the next problem on your own, you should refer back to this video because it can be very helpful. I know it can be kind of long, but it's useful, and this is my strategy for explaining things to you instead of showing it through Zoom through the whole class. So I hope this is useful, that you can go through on your own pace. Okay, I have one more problem to show you, and this is also out of your CPM book. This was actually number 15, and on your practice in class, you're going to be doing, I think I put question B for yourself, so I'm going to demonstrate how to do A. Now this is also a kind of problem that you're going to be doing over and over again in this class, and what it's actually doing is setting you up to understand a skill that you're going to use next year called factoring, which can be used to solve something called quadratic equations, if any of you have ever heard that. When you graph them, they form the shape of a parabola. So this is a foundational skill. And what I have up here, this is always the pattern that's going to be in our what's called our diamond pattern. So in the diamond, the number on the left is x, the number on the right is y. There's x and y. This bottom one is always the sum of x and y. So you add the left and the right together to get the one on the bottom, and this is always the product. So the strategy for this is, well, it depends on which parts you're given, and sometimes you have to work backwards, and sometimes you have to look at possible combinations. A is probably the easiest of the choices because we are given x and y. So it's all we have to do is add them together. So what goes down here is the sum. So that's -9 plus -5. This is why it's really important to know how to add, subtract, multiply, and divide integers, because the rule for this is if they're both negative, then it's really the same as adding 9 plus 5, but saying it's going to be negative. That's 14, and that's negative. So the number in here is going to be -14. Now the product goes on top, and that's going to be -9 times -5. 9 times 5 is 45. A negative times a negative is always a positive. And so we get 45. So I hope you were able to predict the answers before I got them. These two questions will help you with some of your practice, and you will also work together with your group to work through the rest. Ask me if you have any questions.